clear, my p-value is 4%. My guideline for unusual is 10% or less. Is 4% 10% or less?
Yes.
Yeah, so then it's unusual. 10% or less is unusual. This is definitely less than 10%. So this would be called unusual. Maybe I should talk about that. So it's unusual. Reject H naught. Anytime we get something unusual, we reject H naught. So this one over here, maybe at the top I should put this in there because maybe it's confusing you guys. Not unusual. Is that what's confusing, folks? If you get something unusual, you reject H naught. If you get something that's not unusual, then you're not going to reject H naught because it's not unusual. If you get something unusual, that's when you reject H naught. Because H naught says that you are certain, H naught said that my deck had 50% red cards. If you get something unlikely, that means that you probably don't have 50% red cards. We got 6 red cards in a row. That means that we probably don't have 50% red cards because we got something unusual. If we had gotten 3 out of 6 or 4 out of 6 red cards, then we would say, okay, the deck could be 50%. We would not reject H naught. Are you guys understanding what I'm saying?
Yeah.
So, let me see if I can explain to you guys a little bit more. All right, so here's the deal. We have this assumption. We're assuming that our deck is the same as everybody else's deck. My deck is the same as everybody else's. So that's our H naught, is that yours is the same. Then you take a sample. You get something weird, unlikely, like we did, right? 6 red cards in a row, super unusual. Then you'd say that this deck is probably not like everybody else's deck. It probably has more than 50% red cards, like maybe 100% red cards, but something more than 50%, because it's unusual to get 6 red cards in a row if this really is half red cards. So then you'd say this is not 50-50 red cards because I got something super weird. So that's kind of the idea, is you assume that something's true and you take a sample. If you get something normal, then yeah, okay, this must be true. If you get something weird, then you're saying this can't be true because I got something strange if this is true. If this is true and I have 50% red cards, then I should not get red, 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 red. I should get some black cards in there, like, half or so. And we didn't. So that's why you're going to reject H naught, because H naught says that, you should get something typical in this range, that you're right around here. And if you get something over there, then you're not right around here. Hopefully that made sense for people. I have no idea. I can't read your faces, so I'm hoping that you guys got that. So then this last one, my p-value is, so Samantha H, Sam, what would we do here? Would we reject H naught or not? First of all, is 0.24 unusual or not? Tell me that.
It's usual.
Yep, it's usual. So am I going to reject H naught or not reject H naught?
Not reject it.
Yep, exactly. Do not reject H naught because we've got something usual, typical. Okay, good. All right, so we're going to go ahead and move on to the next part. And again, this is what Angel was talking about, like that 0.7, that was confusing, right? 0.7% of male golfers is less than 0.7%. It gets confusing when you have these proportions floating around there, like the 0.7%, which is part of your problem, and you got p-values, which are also decimals, right? So it gets kind of confusing when you have both of them in there, which is why I typically don't do p-values, even though most of the world does p-values. I typically will do the test stats just because I worry about you guys. But a lot of people do p-values, so it's good to know them. But maybe the population proportion, you use percents with that, the percent symbol with that one, and then you only switch it over when when you put into your calculator. I don't know, or maybe use, I'm not sure, but find something that works for you, or just know that this isn't the problem. This only comes up in a couple of steps or something. But just be aware that they're both decimals and don't mix them up. Okay, so now we are going to not get into this confusing other part. I don't want to go there with you guys. We have enough things to worry about. So we are going to circle the bottom part. So if you guys can see this, move this over. So it's this part down here at the bottom. You're going to circle the bottom line, and just in the top line, just put skip or, not doing or something like that. Because again, we're not going to worry about this line here, but circle this bottom line there, the second line. So that's what I care about. Where'd my chat go? Okay, good. So again, circle this part on the bottom, and don't worry about about parts above them. And then we're also going to skip lab problem 2. So lab problem 2, just write skip across that one, or just put X through lab problem 2. We're not going to do that. Good. All right, I do want to talk about how to use the TI-8384. So everybody bust out your TI-84 calculators and do stat test. And for right now, we're going to ignore the options that start with the 2s. But I do want you guys to think about, here, let me show you what I'm talking about. Stat. If I hit stat and test, hopefully you guys can see me okay. So I'm going to mute, I'm not sure who this is, but I'm going to mute them because it's coming into my section for some reason. I'm going to mute everybody except for me, yeah. So can you guys see this okay? Hopefully. Yes, okay, good. So here I did stat, which is kind of this button kind of right in the middle, and then arrow over to test. Just use these arrow buttons here to arrow over to test. And you'll see all these options. You'll see some that end in test and some that end in int or interval. For our hypothesis test, which one do you think you should use? The ones that end in test or the ones that end in int for hypothesis test? What do you guys think? Oh, it's blurry, sorry. Let me pull it back a little bit. Is that better? Test. Yep, the ones that end in test are the ones you should use for a hypothesis test. So you'll notice there's several of them there. There's z-test, t-test, and then ignore the ones that have a 2 in front of them for right now because we're not going to, oops, sorry, I hit the wrong button. We're not going to worry about those for the moment. We'll worry about those in Chapter 9. But then you also see the one prop z-test. So the z-test here, the first one, we're not going to use that one, because that's only when you have a mean and you know what your sigma is, which we're never going to happen. So we're going to use t-test because, again, means, mean Mr. T, t-test. So that's the top one. And then proportions, when you see the one prop z-test, that's the proportion one. So that'll be for one proportion z-test. Okay, so I'm going to go back to sharing my screen. So we'll go ahead and write these out. So again, the z-test, this one we're not going to use, and z-interval we're not going to use also. The t-test is for a mean hypothesis test. The next one proportion z-test, is going to be for a proportion hypothesis test. And then the two that are below that, the t interval is for a mean, t, right? T, mean, Mr. T, it's for a mean, but it's a confidence interval. Because interval, int, interval. And then if you go down a little bit further, you'll notice there's a 1 prop z interval also, and that is proportion, confidence interval. Okay. So do you guys have questions about which ones of these go with which ones? Get my chat up. All right. So we're going to go through I'll talk to you guys through some of the instructions for the hypothesis test. We'll go through those now. First off, I do want to point out, so this is just prettier. Actually, it's not even that useful. It's just, I just did that a second ago. All right, so hypothesis test for proportions. You're going to hit stat and go to tests, and then down to 1 prop z test, proportion test, and then type in the appropriate values. So it's going to be right here. It'll give you this, and you're going to put in P naught. This is, again, this is from your claim, right? Whatever you have in your claim is your P naught. And then you're going to put in your P hat as kind of as a fraction. You're going to have the successes and your n. So here, you do not put in a percentage. You have to figure out what your successes is, and the number of yeses you had, and then your total number of people. So you had to put them in, and you had to put in the x as a whole person. You can't put in 67.3 people. It won't take that because you can't sample 63.7 people. You have to round it to the nearest whole number. And then put in whether your H1 is not equal to, less than, or greater than. So whatever your H1 is, your alternative hypothesis, put that in to there and then hit calculate. And then it'll give you this. It'll give you the z-score, right? In other words, it'll give you your test stat. This is your test stat. And it'll give you the p-value, this p thing here. So we'll go ahead and do these two for out of the quiz. So out of the quiz, the first one, let's do these together. The claim is IQ scores have a mean less than 124. Sample of 19 professors had a mean IQ score of 120, standard deviation of 6. No, this is not on the notes. This is just me ad-libbing and giving you guys some information on how to use your calculator. So, so is this a mean or a proportion? Well, you can tell it's a mean because it says mean right here. So I'm going to go to t-tests. My claim is 124. So my claim is 124. That's going to be my mu. And then this is going to be my n, sample of, that's 19, that's my n. And then my sample had a mean, this is my sample mean, so this is my x bar, and this is my s over here. So, based on the word sample there. So I'm going to go ahead and take a look at all these. So we're going to pick t-test. So go down to t-test and hit enter. And then you'll see where it says data? Yours might be on data. Data wants you to put in a list and stuff like that. That's if you actually have a whole bunch of data. So notice if you have like all the IQs of all these professors, you know, this guy was 132, this guy was 107, this guy was 112. If you have all the information in a list, you can input that and do it that way. But what we have is we have statistics. We have the mean, standard deviation. So I'm going to go over, so it's blinking on statistics, and I'm going to hit enter. So now it's not dark on the data anymore. Now it's dark on the stat. And then what was my mu? Again, mu is from your claim. Find your claim. That's your mu. So my claim was 24. So I'm going to put in 24 there. And then it wants my x bar. That's my sample. What did we get in the sample? We had 20, I think. Is that right? 20 was in the sample. It was 4 and 120, I believe. 120. My bad. Okay. So 124. 124. And then this was 120 and 6. So 120 and 6. And then how many people did we sample? 19. So you put 19 in for your n. And then what was my claim? My claim was less than. So I need to, right now you can see it's on greater than. I need to arrow over so I'm on less than. So I'm going to go down to this part and arrow over to the less than part and then hit enter. So that's not, so right now it's still lit up on the greater than. That's not right. I need it on the less than. So I'm going to hit enter on less than, and now it's on less than. And then hit calculate. Enter. So there is my, there is my test stat, negative 2.91, which is what you guys got on your quiz. And then the p-value is 0.0047. That's really small. So yeah, you should totally reject H naught, which we did. We totally rejected H naught. Okay, good. So now we're going to go back to the second problem on your quiz, which was researcher claims that based upon blah, blah, blah. So 17%, that's my claim. Right, that's going to be my P naught, right, my claim. And then we had 42 out of 200 people. All right. I think that was it 10%? Well, it doesn't matter. Okay. So I'm going to go to stat test again. So we'll go to stat test. And then we're going to go down to one prop z test. So our arrow all the way down to there. Whoops. Shoot. Stat test. One prop z test. So number 5. And then hit enter. Now it's going to ask you for the P naught, and our P naught was 17%. That's great. And then we had 42 people out of 200. So the X is 42, N is 200, and it was not equal to, right? Because our claim was is, so our H1 would be not equal to. So I got to change that. Go over to not equal to. Highlight it. And then it's not done until I hit enter. And all of a sudden, oops, yep, all of a sudden it's not black on the less than anymore. Now it's black on the not equal to. And then hit calculate. So arrow down, calculate. And that gives me a z-score of 1.51, which is what we got. And you see our p-value below that p is equal to 0.13, totally not unusual. So you should not reject H naught. And in fact, we did not reject H naught because 13% is pretty typical. It's not unusual at all. Okay. All right. So we'll go ahead and go back to what we had here. Good. All right, our sample. So this, I spent a lot of time on this slide, so I'm going to go over this one, guys. First of all, are there any questions about that thing we just did? Do you need to do that do you need to do that in terms of the exam or anything else? You do not. You don't need to know how to do that at all. I just wanted you guys to have it in case you needed it. Finding your p-value, that's the easiest way to find your p-value, and it's the least confusing way to find your p-value. So if you need the p-value on the exam, which you will only need for extra credit, you won't need it for the regular exam, but maybe for extra credit, hint, hint, then you will be able to do it that way. Okay, so typically what we do is we compare our z-score, right? That's what we've been doing. So we take a look at our test stat, which is from our sample, right? That's our sample's z-score. We compare that to our gold standard, kind of, our unusual requirement, our usual level, what we consider to be unusual, our critical value. So this part here is sort of, this is set up, all the stuff here on the right, the red stuff, this is all fixed before you even take a sample. It's part of your problem. You decide where your alpha is, and your alpha is what determines what your critical value is, right? You use the alpha, and you look it up on your t-table, and that tells you what your critical value is. So this is based entirely upon alpha. It's fixed for your problem before you take a sample. It has nothing to do at all with the sample, at all. It's just whatever you're going to decide unusual is going to be. You know, you can have alpha be 5%, you can have it be 10%, you can have it be 1%. Then you take a sample, and your sample will have a test stat and a p-value. And you're going to use your formulas, right? Your z-score formulas, test stat minus your mu or your p-hat or p-naught divided by your standard deviation over square root of n to find your test stat. You're going to find your z-score for your sample. So you can either compare z-scores, in other words, compare the test stat to your critical value and see which one's further away from the mean, or you could compare percents in the tail, probabilities, right? So alpha, if it's equal to or less than alpha, then it's unusual. If it's not, then it's not unusual. So you could take your p-value and compare that to alpha. And that's the second way of doing it. So I'm just going to, and because that happens pretty often in the real world, then I'm going to show you guys it. I'm not going to emphasize it a lot this semester just because it's a little more confusing, and I don't want to confuse you any more than I have to just because of the weird situation we're in. But these are the steps if you were to do them, and basically they're the same. Step 1 is the same. Step 2, you're going to have to find your stat test. So that step 3 becomes step 2. And then you find your p-value based upon your, what's wrong with this? You find your p-value based upon your test stat, and that you use using that calculator, the stat tests. And then step 4 is different because instead of drawing a picture and you're seeing whether you fall in the guilty or not guilty range, it's going to be comparing alpha and the p-value. And if p-value is unusual, in other words, if it's less than alpha, less than or equal to alpha, then you're going to reject the H naught. And then summarize your results. So really it's only step 3 and 4 that are different. These are written in the bottom of this page, bottom of page 17. And, just it's another way of doing it. It's an alternative way of doing it. So what we're going to do these last few minutes we have is I'm going to do you a quick example. So here's an example comparing alpha and p-values. So here we have a physician claiming that the average, that joggers' oxygen is greater than the average of all adults. So in other words, he's claiming that joggers' average, I know this is going to be a mean because of the word average, their mean is greater than everybody else's. What's everybody else's? Now you got to figure out what everybody else's is. Let's see, everybody else's is, average of all adults is 36.7. So then you have to find the sample stuff. So find the word sample. Sample, so this is all about your sample part. So here's your sample size, 15. Here's your sample mean, 40.6, that's your X bar. And then you have your sample standard deviation, that's of 6, that's your S. All right, so then I got to figure out, the other thing we have is our alpha. Alpha is 0.05, that's our significance level. Great. State the hypothesis, identify the claim. I'm claiming that mu is greater than 36.7, so my claim is going to be that, So my H naught is always, always, always equal, so my H naught is going to be that mu is equal to 36.7. Remember, that is my mu, that's the general mu, and then H1 will be that mu is greater than 36.7, and that's my claim. So I'm going to be using the word support later on because, again, rejecting H naught supports my claim. And then I'm going to look at step 2. Step 2 is is computing the test value. So I would pop these into the calculator. I do, let's see, it's a mean, so I do t-tests. And when I do t-test, I pop in all this, test value, my bad. Test value. So we're going to do X bar, my sample mean, minus mu, what I got from my claim. Remember, this mu here is the same mu as you have in your claim always. It's the general mu. And then divided by S over square root of n. So I'm going to get 2.517. And then we're going to take a look and figure out what the p-value is. And then for the p-value, I want you guys to use the calculator for that part. For the test value, I still want you to calculate it this way. I'm going to make you do the work so you understand where it comes from. So you're going to use stat test, and we're going to just do t-test for here, right? Because it's just a regular, it's a mean, and it's a test. So it's a mean, so it's going to be t, and it's a test, so we're going to put test there. So you're actually typing this in, writing this in. This is what you're supposed to hand in today. So this is your notes for today. And then we're going to do this. So stat test, t-test, and you're going to put in these numbers here. And if you do, just for right now, you can write in what the p-value is. So just for this part here, step 3, write in stat test, t-test, and then write in p-value is 0.0123. Is that unusual? 0.0123. My alpha is 5%. Is that less than 5%? Yeah, it's totally unusual. Absolutely unusual. Which means that we're going to reject H naught, right? Step 4 will be rejecting H naught. Because the p-value is less than 0.05. So then step 5, because we got something unusual and rejected H naught, then we do have enough evidence to support, because again, H1 is my claim, the claim that Jagger's maximal volume uptake, I would say, just say Jagger's oxygen uptake. You don't have to put this part in there. Jagger's oxygen uptake is greater than 36.7. So that's it for this part. Lab problem 4, you're going to be turning this page in, this page 18 in. So for lab problem 4, just in here write in didn't do yet, and that's fine. Just take a picture of this page where you've done the first example. That's your work for today that you're supposed to turn in to show that you were here today. And then for lab problem 4, just write in small letters, just put, didn't do yet or something like that, or you're doing next class or something like that. And then take a picture of that and send that in, and that'll be good. Okay, so have a great couple of days, and I will see you guys on Thursday. And perfect. I think is Ian still here? Ian, Corey, give me a hello before you go.
Yeah, I'm here.
Great.
Yeah, I'm here.
Good. And then Anjali, are you still here? I don't know if I saw you.
Yeah, I'm still here.
Great. And then Robert. All right. See you guys. Have a good one. Thanks, Robert.
Thank you.
Bye.
All right,
Take
bye.
care. Thanks.
Bye.
Bye.